Here we go. So this is Unit 9, which is sequences, L'Hopital's rule, improper integrals, and something about related rates. So, all right, question number 1. Which of the following gives the value of the limit as x goes to 0? So first things first, we plug in 0. If you do that right, you'll find that the limit as x goes to 0 gives you 0 over 0. So that means do L'Hopital's rule. Derivative of the top is going to be 4/3 x plus 1 to the 1/3 minus 4/3 all over 2x. That also, when I plug in, equals 0 over 0. It's a little annoying. So yeah, do it again. This one's going to drop. Bottom becomes 2. So you know you're either going to get 0 or you're going to get a number. And the top becomes 4/9 x plus 1 to the negative 2/3, which you plug in 0, you get 1. 4/9 is divided by 2 is 4/18, which is, I believe, 2/9. Which of the following gives the limit as x approaches 0 from the positive side, 3x to 2x? Well, plug in 0. You get 0 to the 0, which is one of the cases we've learned how to handle. We got thing up the exponents, so we take a natural log and we throw the 2x out front. But that's no good. So we're going to want to throw the x on the bottom. We go 1 over x. We can actually break this apart better than that. And let's leave it like that for now. Let's see what happens. So we say limit as x approaches 0. And we go 2 ln of 3x over 1 over x. Flip it up, it would end up here. Which ln of 0 is negative infinity. That's why it's from the positive side. 1 over 0 is infinity. So L'Hopital's rule, take the derivative. Derivative of the top is 1 over 3x. 2 comes along for the ride. 1 over 3x, chain rule times 3, over x to the negative first is negative x to the negative second, which becomes 2, negative 2. X flips up, we get x squared over x. See ya. Negative 2x. Limit as x approaches 0 from the positive side of negative 2. X is 0. We think 0. No. We go e to the 0. I think I forgot something. Oh, I want to break this up first because otherwise my 3's cancel. So I'm going to cross it out. I'm going to come back here. Actually, I'm even going to go one further back. I'm going to go here. So let's make sure I do this right. Oh, I've read the question wrong. This is not what it said. That's why I did it wrong. Fun to make mistakes. All right, so let's try that again. We're here. This is wrong. That is 0 to 0. Let's come up all the way up to here. Paper got lost. Very upsetting. And we change this to ln of 3 plus ln of x to the 2x, which becomes ln of 3 plus 2 ln of x over 1 over x. Now this one is fine. We keep that. We don't touch it. All right, got an answer there. We can take the limit as 0 goes to x goes to 0. It's ln of 3, so don't touch it. So ln of 3. Now we do the derivative. 2 over x, negative 1 over x squared. Ln of 3. Flip it up. We get negative 2 x. That's plus if you want to go there, negative 2x. And then limit as x approaches 0 from the positive side of ln of 3 plus negative 2x gives us ln of 3. E to the ln of 3 equals 3. Sorry for making that quite such a mess, but that's a good example of reading the question carefully. This is a very common AP problem you're about to see. You look at it and kind of freak out, and then you realize 2 to 2 gives me 0, 2 squared. Oh, all right, this is L'Hopital's rule. So derivative of the top means that the 2 and the x cancel out. You're just left with sign of x. Derivative of the bottom is 2x. I actually know this one is going to be 1/2, but that's okay. Oh, whoa, whoa, whoa. See, look at that. We make an assumption. It's going to put 2 in. So limit as x approaches 2, sine of x over 2x equals sine of 2 over 4. Very nice. Which of the following functions grows faster than x squared as x approaches infinity? Now, I can do a bunch of these. Oh, goodness. I can do a bunch of these, but I already know. Grows faster than x squared as we go to infinity. Well, this goes to 0, so that's a no. This just kind of slowly grows, so no. This is x, and it also slowly grows, so no. And this is 2x squared minus 3x. Now that grows at the same rate, not faster, because they're both the same power. Which leaves me only with this one, and it's x to the third, so it's going to grow faster. Prove it. Limit as x goes to infinity, 0.1 x to the third over x squared, cancel, cancel, equals 0.1 x goes to infinity, which means that the top grows faster than the bottom. This grows faster than that. This is a classic. Find all the values of p for which the integral converges. I see this one a lot. And we go to 1 to infinity. So you say, oh, what's going on? Well, I don't know how much we worked on this. This is really an integral test. If p is 0, this is no good, because that's if p equals 0, then we get integral 1 to infinity of d of x over x. Do the whole improper integral, we get ln of x as ln as x goes to infinity, ln of x. So that's no. Can't have 0 in it. So less than -1, less than 0, greater than 0. So it really doesn't help me out at all here. Let's see if I can do better than this. How about if p equals 0.1? Let's see what happens. Get limit, and we do all this nonsense as a goes to infinity. Integral 1 to a dx over x to the 1.1, which limit a goes to infinity, -10 x to the -0.1. This is x to the -1.1. We add 1, get -0.01, that right there, and then divide by it. And that's like multiplying by -10. Now we do this from 1 to a, which is limit as a goes to infinity of -10 out front, a to the -0.1 minus, I believe you're going to get 1 to the 1.1 to the -0.1. That's 1, so that one's just going to stay there and become 10. And this is basically the same as 1 over a to the 1/10. So as this goes to infinity, this goes to 0, we end up with, this is 10. Just get rid of that, equals 10. It's very confusing stuff. So as long as it's greater than 0, 0.1 is greater than 0, it works. Anything smaller than -1, it's not going to work. That's a horrible question. I don't really like the way it's written, so my apologies. Oh, hey, look, looks like another one. Find all the values of p for which the integral converges. So in this case, this is the same problem. Why did I do that? That's weird. I'll have to fix this in my note packet. So bye. No, it's not the same problem. I just crossed it out. That's funny. 1 to infinity, 0 to 1. My bad. All right, so let's try p equals 0. So lame. P equals 0, we get the integral from 0 to 1, dx over x, which is ln of x, 0 to 1, which is undefined because I can't take ln of 0. So we can't have 0 in there. If p equals -1, integral 0 to 1, dx over x is 0, which is 1, we get x 0 to 1, which is 1. That's okay. So here we go. -1 works. I'm guessing we're going to be less than 0. Let's try -2. Integral 0 to 1 dx over x to the -1st, which is, bring up the x, we get x squared over 2, which is 1/2. We're okay. So anything less than 0 is going to work. That's horrible. It's horrible, horrible, horrible. I almost recommend not doing those problems because I think they're so horrible. I actually don't even mind crossing them out. But that's Unit 10 stuff. We're going to get there. Free response. Second, fifth term, find the first term, all this fun stuff. Uh, 1/2 equals -4 r to the third. R to the third equals -1/8. R equals -1/2. So we're going backwards. So A1 equals 8. And then the common ratio, R equals -1/2. What's the rule for the nth term? A sub n equals 8 -1/2 n minus 1. Cursive rule for the nth term. A1 equals 8. An equals a sub n minus 1 times -1/2 n is greater than or equal to 2. Consider the region under this. Write the area of R as an improper integral. So I would have to graph this first. I believe it looks something like this. Plug in 1, 0, we get 0. So this point is 1, 0. And then it gets closer and closer to the x-axis as we go out to infinity because the bottom goes really big and the top doesn't go as big. Yeah. First quadrant under the curve. All right, so this is going to be an integral. 1 to infinity, 2 ln of x, x squared, dx. Express the integral as a limit of a definite integral. This is the nonsense we've done in class. A goes to infinity. integral 1 to a to ln of x over x squared dx. Find the area of R. Always something. Integral without the limits for the time being, 2 ln of x over x squared dx. Let's try some u substitution. U equals ln of x, du equals 1 over x, dv equals x squared, v equals x to the third over 3. Don't like the way I wrote that. Okay, equals negative second. X to the negative second. Add 1, negative 1. And I'm going to keep the 2 up here. Whatever. Add 1, negative 1, divide by it. We get 2, negative 2x to the negative first. So we get negative 2 ln of x over x plus minus 2 integral. This would be over x, so it would be x to the negative second dx equals negative 2 ln of x over x minus 2 over x. Limit as a goes to infinity. What's going on? I factored out negative 2 ln of x over x plus 1 over x, 1 to a, equals limit as a goes to infinity, negative 2 ln of x over ln of a over a plus 1 over a minus 0 plus 1. This grows pretty slowly. This grows faster. This grows faster. 0. So we're done. Equals 2. Onwards. Consider the infinite region R in the first quadrant, x e to the negative x squared. Write the area of R as an improper integral. Area equals integral 0 to infinity x negative x over 2 dx. Now do that whole same thing. Limit a goes to infinity, integral 0 to a, x e to the negative x over 2 dx, and then go find the area. U equals x, du equals dx, dv equals e to the negative x over 2 dx, v equals negative 2e negative x over 2. Limit a goes to infinity, negative 2 x e to the negative x over 2 minus integral 2 e to the negative x over 2. Not bothering putting in the limits right now. Limit a goes to infinity, Negative 2x e to the negative x over 2 plus negative 4e to the negative x over 2. Equals limit a goes to infinity, negative 2a e to the negative a over 2 minus 4 e to the negative a over 2 minus 0 minus 4e to the 0. Wow. Equals, so e goes to negative infinity. It grows faster than this, so it's going to dominate. That's 0. You can just throw it on the bottom if you want. That's also 0. So we get 0 minus negative 4. 4. Ooh, that's tough math. Infinite region. Sounds like a theme. Blah, blah, blah. Revolves about the y-axis to generate a solid. Improper integral. Or on the y-axis, huh? If I'm not mistaken, this will graph 1 over x does this, minus 1 will do this. First quadrant, so I'm not going to do this one down here. And where does it hit? Y equals 0, 1, x equals 1. I'm guessing this is 1. So I think we're going to go from 0 to 1. I got to think about this for a second. Well, regardless, it's going around the y-axis, so let's get that done. Y equals 1 over x minus 1. Y plus 1 equals 1 over x. X equals 1 over y plus 1. Let's see if I was right. I want to get 0 here, so I plug in 0, I get out 1. So yeah, it's right there. So I think I've done this problem wrong before. That's okay, it's kind of fun. All right, the volume is pi r squared. X is that, pi, integral from 0 to 1. Now I'm just making sure I'm not insane. Infinite region in the first quadrant by the coordinate axis and the curve y equals 1 over x minus 1. Yeah, I think that's right. So what's the x value? 1 over y plus 1 squared dx. And 0 to 1, but 0 is a problem. 0 is actually going to infinity. So the volume is limit as a goes to 0, pi a to 1. Interesting. Nobody's ever yelled at me about this before. They should have. I'm betting. Goodness. dy. That's all they wanted. And then find the volume of the solid. I'm very confused. Give me a moment. All right, so this looks horrible, but it's not. This is just y plus 1 to the negative second. Integral of that means add 1, get 1. It's negative 1 over y plus 1. I was waiting for a much harder problem. Pi a to, whoops, get rid of that now. Negative 1 over y plus 1, a to the 1. Limit a goes to infinity. Sorry about that, everybody. Pi, 1's on top, negative 1 over 1 plus 1. Yeah. Minus negative 1 over a plus 1 as a goes to 0 equals, as a goes to 0 equals negative 1/2 plus 1 equals pi over 2. Not the original answer I got. Very upsetting. I'll have to check that one, make sure I did it right. And determine whether this sucker converges. So u equals x, du equals dx, dv equals e to the negative x dx, v equals negative e to the negative x, equals negative x e to the negative x. The integral of this is going to be, minus minus, so it's e to the negative x will be minus e to the negative x. Limit as, let's just go with b for the fun of it. And we just throw it all in, negative x e to the negative x minus e to the negative x, 0 to b, equals limit b goes to infinity. I'm going to factor out my negative e to the negative x, which I really should put on the bottom, leave me with x plus 1, 0 to b. Yeah, I will put it on the bottom, equals limit as b goes to infinity, and I'll throw the negative out front, negative x plus 1 over e to the x, 0 to b. When I put in infinity here, I get negative, let's b first. The bottom's going to grow faster. Negative infinity plus 1 over e to the infinity. This grows faster, so that's 0. Minus, now plug in 0, get 1 over e to the 0. This is 0 minus minus, we get 1. All righty. So it converges. And it converges to 1. Why? Because we're able to take the integral. Fix that. If you take the integral and get value, it converges. Very nice.